Hello everyone, my name is Chinyi Li. My paper ID is 308, and my title is User Experience of Taiwan Railway Ticket Vending Machine. For achieving the goal of self-suffice, the railway ticket vending machine must be a good interaction between the system and the users, which means not only the functionalities need to meet the user's needs, but also the operation must feature usability and learnability. On the other hand, user operating outcome will be impacted by self-efficacy, and the mental model also interferes with the user action and learning. The Taiwan Railway is vital infrastructure in Taiwan, and it launched a new TVM in 2021. Compared to the old one, it includes many new functions, such as ticket returns or bicycle-friendly chain, allowing users to perform different operations on the system interface. For observing the overall TRA TVM, we do 8 different tags on these systems, including 5 ticking tags and 3 functional tags. About the participants, 97 volunteers were ranked by their self-efficacy score. The first third as select as the high self-efficacy group, and the last third as the low self-efficacy group. Each group have 18 participants. For a total of 36 wild participants, 16 males and 20 females, aged 20 to 59 years old. The test process consists of 4 steps. First, participants need to complete the pre-text questionnaires and the TVM main function sorting. Second, operate 3 tags with orient situation. Third, do the semi-structured interview. Finally, ending the questionnaires like SOX or quiz scores, and resorting the main functions. Compared to before and after operating the tags, the increase in acceptance of ticket purchase type first was higher, but there was no way to tell which process was more appropriate, as each had its supports after operating. The participants' performance showed that Q5 had the highest error rate of all system functions. In terms of the error rate at each steps of ticking, the error rate was higher when selecting Step 1, Ticket Purchase Type, and Step 2, Time Station. About the reasons for the error rate from participants' feedback were categorized into 3 accepts. First, 10% for the error rate reason is being influenced by the mental model. Second, 24% is unnoticed the operation of the systems. And the last one, 66% is confused about how to operate. In mental model, the most frequently mentioned being that about 42% participants did not think the departure station should be preset when operating the Q1 tags. About the unnoticed accept, Q8 was the tags where the most unnoticed occurred. For example, 58% of those tags indicate that they did not notice the intervals of the value 8 when operating. Additionally, confused was the main cause of errors in all 3 accepts. At the same time, it was most likely to occur in Q4 and Q5. In Q4, 92% participants say they were unsure of the color difference in the navigation bars. When observing the self-efficacy of participants, it showed that the high self-efficacy group entitled mental model are more different from the TRATVM before operating, but after operating they changed their mental model to the same as the TRATVM. The number of errors made by high and low self-efficacy varied between tasks. This means participants' confidence in operating the TVM alone did not necessarily affect actual performance. On the other hand, it was surprising that there was a discrepancy between the performance and the elevation. The high self-efficacy group's performance on the ticking task was better, but the average on quick score was lower than low self-efficacy group. Given the pre-text sorting results, the high self-efficacy group only had 16.7% of participants' mental model coincide with the TRATVM ticking process. Therefore, they may feel more frustrated than the low self-efficacy group. In the interview, the high self-efficacy group generally cite confused or unnoticed more often than the low self-efficacy group across several tasks. The interview also revealed that high self-efficacy group trust their judgment during operation more than low self-efficacy group. But it was more important for following the instructions to complete the task. For self-suffice, the error rate showed that there is still much room for improvement in the TRATVM. It was found that the user mental model not only influenced performance but even the degree of difficulty in the process. Besides, self-efficacy does not directly affect performance, but as a belief, indirectly influence the outcome. For the future, priority could optimize the step 1 and step 2. Also, it is worth exploring whether to follow the mental model and how the design can strike a balance between high and low self-efficacy users. As a result, we do the second study for optimizing the system. In this study, we explore the ticking process and redesign the interface in which participants made more errors when operating. About the ticking process, we have 3 versions. The version A is to choose the ticking type first, same with the TRATVM. And version B is to choose the time station first. The last one, version C, is do not need to choose the ticking type. About the interface, we remove the station button colors, redesign the navigation bar, and add the direction of information, and so on. Then we use a similar method to previous study, like sorting the main function, operating a situation text, forming the questionnaires, and sorting the favorite versions. We got 36 participants, with 16 males and 20 females, aged 20 to 65 years old. No matter optimize operate version 8 or B, the participants' mental models intend to choose the departure arrival station first after operating. Only on version C was participants had the same percent on each version. The results showed that participants had the fewest errors in version C, and participants' performance of all 3 versions were better than operating the Q5 tags in TRATVM. When observing each steps of errors, version B can make participants have the lowest error rate in each steps. In the interview, participants described the A version as smooth but having more steps. Version B is simple and smooth. Version C is information integrity, fast, but shock and overload of information. As a result of their sorting feedback, version B is the favorite version of all participants, and they had polarized favor on version C. Overall, in the ticking process, making the time station first or without ticket purchase type can have fewer errors than with the ticket purchase type first. In the future, when optimizing the TRATVM by the feedbacks of participants, version B can be used as a common ticking process, and version C can be used as an express ticket purchase. Thanks for your listening. This is all of my presentations.